Today on the bench we have a motherboard, a Dell OptiPlex 755 motherboard, which is about the value of $20. I actually bought this one for $5 plus $15 shipping, and I had an option to buy it for $20 with free shipping, so I went for the one that ships with the UPS. And when it came to me, I didn't have memory for it, so I just turned it on. It was beeping because of no memory. It did turn on and everything. Processor started heating up, the chipset started heating up, so I concluded the board is okay. And then I got some memory for it, and it took me a while to actually gather all the elements I need for it to become a computer. I even tested a graphics card, and like this big one, and it did show up the image with saying that it's lacking external power, which I didn't connect because I didn't have sufficient power supply to actually power it up. So I concluded that the board is okay. Now after a while, I hooked it up with either tried it starting it from the pen drive, Linux, Windows from the SATA drive. It goes through the BIOS, it detects devices and everything. As soon as it tries to boot up, it just freezes. Nothing happens. The keyboard doesn't work, the mouse, nothing. But you can enter the BIOS and you can actually, configure stuff in the BIOS. So it just won't boot up. And I figured I could fix it, because usually the only thing that breaks here are the capacitors. They either explode, they swell, or they dry out. Either way, they just lack capacitance, and that is most likely the reason. The other thing could be that the power supply was damaged and it just shot too high voltage. But in such cases, it usually doesn't act like this. That when the board has been fried by a PSU, then usually it won't even boot to BIOS. It won't even see any image, because it's usually the memory or the processors, everything that works on 1.6, 1.8 volts. That's what usually gets damaged. So I'm pretty sure this is all capacitors. So I'm gonna just run some tests, see how many caps are showing up as open lines, and replace them and see if that works. But it's pretty safe bet that this is the issue and the board should work again. Let's get to it. Alrighty, let's see what we got here. And no, I'm not wearing gloves because I'm afraid of leaded solder, which should be the reason actually. It's this time of the year that there's tons of electrostatic charge everywhere. You wear sweaters and long johns and all that, and that I'm basically shorting everywhere. Everything I touch, there's a spark. So I don't want to fry the board, and I don't have the discharge clip for my hand. And actually the grounding in this building is not that great, so well, this is one way to mitigate electrostatic charge. So we have plenty of caps here. Let's just check randomly some of them. It's taking a while, so it's going to be open line. So this one's bad. This one's taking a while, so it's going to be the same thing. Open line. This big one. The big one, also open line. Not a single working capacitor here so far. And this one's open line. Measuring capacitors in circuit, it's not very reliable, but it's good enough to just spot the capacitors that plainly don't work. Oh. There's not going to be a single one that works. Come on. This one works. 279 microfarads. Which one is this? So amongst those 4 that I tested, only this one actually shows up as something. So let's do this. Let's just mark them all with a nice little X. So I know these ones need to be replaced, and let's move on to these little ones over here. I can already tell by the time it takes to measure. It should show up after about a second. And the meter I'm using looks like Fluke, but it is not. It's some cheap Chinese multimeter, but I find that this one has the best accuracy when it comes to measuring cups. Okay, so this one is good and those 2 are not. So these 2 need to be replaced. This one's good. Let's see this 105. This guy. Also done. Damn, that's a lot of cups. I was not expecting this many. I thought I'll find maybe 1 or 2 that are dried up. The ways they break, there's only like three ways they break. These ones, since I don't see them being partially exploded or bloated, swollen, nothing like that. So they're just dry. And these are electrolytic capacitors, so meaning there's an electrolyte inside. And if it's gone, then the cup just turns into open line. At least these ones, because ceramic ones, they turn into a wire, but usually through either voltage too high or physical damage, because it's kind of a series of little plates that kind of intersect like this, but they cannot touch. If you break it, then they're gonna start touching, and that turns the cup into a wire. All right, that's a lot of cups. These 2, let's see. I don't think I even need these for the motherboard to work. Let's see. Nope. This one's done. Oh. 1.6 millifarad. It must be in parallel with something else, because there's no way this is 1.6 millifarad. 220 micro. It does show up as something, but I'm gonna mark it as damaged as well, because it's giving me weird measurement. But as I said, measuring in circuit can give you weird readings. So this is not to measure the actual cups, it's just to find which ones are completely not working. And this one also shows up as 1.6 millifarad. That is weird. That is weird, but let's mark it as well. And So did I not test these two, or were they okay? This one and this one. Actually, maybe I can just put it like this so you guys can see. This one. Open line. And this one. Open line. So these two are also done. These are very important ones because these, even if they break, then you have problems with the display and stuff. But these ones, yeah, they can definitely cause the issues I'm having with this board. This one. Open line. This is a very old board, so this is to be expected. Caps are usually the reason for all problems with electronics. And since these are high capacitance capacitors, then, and they are not, since it's a purely digital device. 0.9, so 1000 microfarads. Let's see if it is. I don't think it is. I can't see. I cannot see. Oh, these are 105s. I'm gonna replace them with 85s. 220. Not 1000, but again, it might be in parallel with other caps, and that's why it shows up as higher one. And let's see these four over here. Uh, 354 microfarads, that's close enough. I don't want to replace all of them. The ones that do work, I'm going to leave them for now. 350, the same thing. And this one. And that's going to be open line. Oh, but it shows us 1.7 millifarad. That's huge. So these are good. So on this one is open line. So these two were good. Let's see. This one is likely for the USB. It's close to the power input or voltage input, so it might also be relatively important. But as I was saying, this is not analog device, so the strict capacitance is not as relevant as long as it's within certain region. 353 micro, so this one's good, and this one. In analog devices, you know, the capacitance is very important because it might be, you know, the time you push some current through it and it keeps charging, and that charging time is important. I don't know, this one shows up as like really huge capacitance, so I don't know I'm gonna replace this one too. And 3 more here and 2 more here, and we're done. So these just basically stabilize voltage, nothing more. 5 microfarads, that's not enough, regardless what's connected. This one, 7 microfarads. What are the values on these? Maybe they are this small, but I've never heard of 8 microfarad. Oh, 4.7. These are high voltage, 50. And what was I getting? Yeah, that's close enough. So these are good. And one last one over here. .5 millifarad, huge capacitance. What are you? It could be 1000 microfarads, so that would be 1 millifarad. But I can't see it. Yeah, I think it is 1000, so this one's good. Okay. Now the other thing that I see over here, I don't know if you can spot it here. Let's see. See that big hole in the battery? That shouldn't be the cause of this issues I'm having with it. But let's see if that battery even works. Judging by what it looks like, I wouldn't expect it to work. What do we got? DC, and we have 1.8 millivolts, so the battery is done. It should just issue a warning, and obviously your clock is going to reset every time you turn off the computer, but I really don't care about that right now. Now let's start removing those caps. Let's see, 280, 320, that should be enough, even too much, that's fine. And let's get some scope. Okay, well, the board is also pretty dirty. But that shouldn't be an issue either. Might be some cold solders, maybe. My ultrasonic cleaner is not big enough to run devices like this. So that only leaves me with a alcohol and toothbrush. That's what I'm gonna do, but I'm looking for some potential physical damage before I start recapping it. And definitely seen better days. I don't see any huge damage to it, nothing like that, like broken traces or cracks on the board or some obvious soldering issues, nothing like that. So, let's see. Let's get these Actually, it'll be easier if I just mark it like that. Let's turn this guy off. And these two, so this one, pretty much all of these, all of that, these two guys, this one and this one, this one, and these two over here. Oh, just these two, not that one. That one's good. Further, this little guy, and that's it. Now let's get some no clean flux. Less aggressive than RMA. Either way, I've cleaned the boards afterwards, so that's not a big issue. But it's better to use non-aggressive or non-corrosive flux if you can. We'll see how many layers this board has, but my guess is plenty. So we'll see how it's gonna be behaving when we heat it up. And I'm gonna use the wick and wick it first. You could technically heat it up and just pull it from the other side, but that's a very aggressive method. You're risking the damage, especially when you have boards that have this many layers and traces are tiny. Rip one trace off and it's a nightmare. Let's start with this guy. Let's see. Let's heat it up. Oh, I want to flow. I might need to put some leaded solder. Actually, low melt would be better, but I only have it in the form of paste, and it's full of tiny little balls. And once you heat it up, they tend to just fly everywhere. So it can be quite a hassle. Try the regular leaded solder, like what is it, 183 degrees. Flow. Flowing a little. What did I forget about? Anybody? I forgot about my lungs. Let's give it just 40%. And use higher temperature. I could, but I don't want to heat it up too much. Oh. Fume extractor got in the way. There. That's better. Still more flux. And see if we can lick it. If not, I'm gonna have to use the roll melt. The board is sucking up all that heat. So let's go crazy on 380. And the flux is already burning. Yeah, there's no clean flux. Burns it much quicker than the activated flux. So I wouldn't recommend this one for like connectors and stuff, because it's just gonna burn too quickly. But for cups, it should be fine. Doesn't really want to cooperate with me. But all right, there we go. Looks like for what did I do? 380 was a trick. There, almost there. It's already burning my fingers. Come on, don't be like that. What is on the other side? Can you believe it? Cups shouldn't be this difficult. It's not letting go, so let's just treat it like a difficult cup. Okay, cup number one. if I put more solder on it. I'll try with the next one. See if that's gonna make it easier. Gonna catch my wick. I don't like that. It does not look good to me. From this side, I don't know. Let's give it a drink. And I don't know, did I do that? I'll have to review the footage later. But did I mess up these? I'm pretty sure I did. And I have no schematics for this board. So that's gonna be fun. For now it doesn't seem like like the trace has been broken. I could check, but let's see what this capacitor is. 220 microfarads, 85 degrees. Crap, I've been using the activated plex. I thought I was using no clean. Yeah, it did seem different because I have different nozzles on those. 220, 220. What's the voltage? 10 volts. 220, 10 volts. So it should be second from the left. Let's see. 220, 10 volts. And I didn't check the polarity, so now we need to figure out where the mouse is. Oh, it's marked on the board. That's good. So that's all good. There we are. Now the actual no clean. Okay, one down and like 8 to go or something. Oops. Now let's see if we can speed up the process, because if it takes this long to recap it, then it's not really worth it. Especially for the board. That is literally a pocket change. Get there. Okay. More flags. A lot. Got it. Okay, let's get some fumes. Oh, this one actually went well. Let's see here. Oh, okay. This one was not as difficult. Probably still holding on the other side. And that's how I damaged the other one. Alright, that's not good, but will do. And this guy is 220, 10 volts. Oh, the same one. Okay. Not perfect. Hmm. 220, 10 volts. It's also important for the cap to be sitting as close to the board as possible. For very boring reasons. And some clean here. Not too much, not too little. Too much is not good for the caps. And obviously too little is not good either. This guy and this guy. Alright. Next subject. Yeah. Let's get some more. Okay, film extractor. Layer jab. Keep me from getting cancer. Too fast, too fast. Come on. Yeah. Yeah, almost. There. This guy. Almost there. There. Perfect. That's a very unfortunate position. There. That's one guy. What are you, little fella? You are 220 at 10 volts. And they're all 220 at 10 volts. That's good. I have plenty of these. Well, actually not plenty, but enough to fix this board. And the clear markings on the board make it so much easier. A lack of light, not so much, but I can manage. Okay, cup number 3. Cup number 4. Oh, I'm gonna have to cut this one, I think. Oh, we'll see. It's relatively important to cut them as close as possible, but not to go crazy with it. Last time I was fixing the light, you can find a video of it. It was cut way too much, way too much. Way too close to the board, so like half a soldering was also cut. That's not ideal. Oh, first more solder. Oh, I'm gonna have to pull it anyways. Or maybe not. Yeah, I didn't. Okay. It went out 220 at 10 volts. Two twenty at 10 volts. Negative, positive. that. And this guy. This guy. Okay, next one. This in here. This one doesn't want to play. That's alright. That's fine. We can we can dance for a little while. This one's gonna have to be pulled. It does not want to play with us. Let's see, on this one looks like it's 105. See if I'm gonna have one like this. 105, 1800 microfarads. No way I have one like that. Let's see, I got 105 over here, which is 1 micro for 50 volts. What's the highest I have? 1000 at 16 volts. What's this one? This one is 6.3. Well, you're gonna be 800 microfarads short. I'm just gonna use 1000. It's not ideal, but it'll work. It's better than 0 that it has right now, so that's for sure. Okay, and these two big ones. Oh, I don't care what they are. I'll find the nearest replacement if it's not the same, because any capacitance will be better than what we have right now, even if it's not exactly the same. And it's hard to have every possible capacitor in stock, especially when you do stuff like that out of your apartment. Small apartment, might I add. Running out of wick. This one, since I'm already here, it should take a little less time. And then just replace them both. So good. These big ones, they dissipate heat a lot more than the little ones, so it's hard to just soak up all that solder. So I will have to pull on them, but at least there's just going to be a little bit of solder left over, so it will be a lot easier. It will come out cleaner. That's the best we can do for now. Now let's pull the guy. Oh, these are big. That's one, and gamma. Doesn't want to play. And I keep scratching the board, which is not good. Not good at all. Do it this way, otherwise it won't come out. Have to put some solder on it to dig it out. 220, I mean 2200 on 6. Well, again, we're replacing it with 1000. I could do 2 1000s in a parallel, but this is mainly, right now, I just want to see if this will help and whether the board will actually start working, booting, because it might not be the only issue with this board. Obviously, that is an issue, for sure. But it might not be the only one. Yep. There's still some solder left. Yeah. Because I removed it without the microscope, and this is a bit too small to do it without any magnifier. Even a head magnifier would suffice. How did I get it? Nope. Still clogged. This one's good. This one's clogged. Well, there's probably lead-free solder left on it. So let's do another mix and match. Mix it nicely. I gotta do it from the other side. That sucks. Big caps are a pain. It's from this side you need to maneuver in between all those other caps and other components in the way, connectors, all that stuff. Oh my god, what is this? Why are they behaving like that? Alright, now we got it. Now we got it. And the negative goes here. Let's test it. Positive, negative. Okay. Now it's working. Damn, it's so much smaller than the other ones. It's dirty all around, but I'll just clean it all in one go. A little more, a little more. There. Yeah. And the one next to it also won't get out. Okay. And this is also 2200, 6.3 volts. So if the caps were the issue, which most likely they are, then it should work with those smaller caps. And if so, then I'm gonna just order these 2200 6.3, because these are actually pretty popular. I don't know why I don't have any, especially with motherboard repair. There's plenty of these always everywhere on the boards. So I should have some in stock. Yeah. And these two big ones, they're also 2200. Run these two and the board should start working now. Would be my guess. Because these are quite important. All of them are important, but these in particular. That's why the capacitance is so high, because that's what powers up the chipset and maybe a CPU. Hard to tell, but big capacitance means we need to stabilize a lot of current. Okay. That's the rest of the wick. So now it's gonna burn. It will burn a bit. Okay, now let's get them out. Not these though, these. Yeah. Okay. Number 1 and number 2, come on. There, so that's 2200 at 6. Okay, do we have holes? Nope. This one we do, and this one we don't. Let's get this one cleaned. I can probably still use this wig. Let's see. Okay. And 2 cups, 1 and 2. And positive goes here, there, and the other one. Positive goes here. Okay. Oh crap, how did that happen? Okay, I'll fix that in a second. One of the cups didn't go all the way through, or all the way down to the board. There's like a gap. So I'll fix that in a minute. Okay. Alrighty. And the one cup that didn't want to go all the way down. Let's just do this. I'll warm it up and push on it. Let's go like that. Okay. And now let's check this soldering on it. made a bit too short, but it's nothing very alarming. Ay, come on. Don't be like that. And there. This one could go a little more too. There. Okay. Now it felt like it's set. Alright, and quick inspection. Yep, looking good. Just 30. Okay, that should do it. Because these two, no, there's one more cup over here. And that's it. But that cup is not responsible for anything that would prevent the board from starting, from booting. So alcohol here, capacitors. Very handy set. As you can see, it doesn't have everything that would be required for this board, but it has enough. And these are our cups and a whole bunch of mats. And now let's just clean it. A lot of alcohol here. Let's just quickly clean this, all that stuff. Like, I don't know, that was like dust probably with something that makes it kind of almost solid. It shouldn't be the issue, but won't hurt to clean it. Okay, and now let it dry. And let's give it a test. The chances that this helped are very high, but it's not 100%. Back in the day, and back in the day I mean like maybe 2 decades ago, it was a pretty good business to buy broken or not functioning motherboards on eBay or some other sources, and a lot of them would just require recapping. Caps are relatively cheap, relatively easy to replace, and from the board you bought for $15, you can sell it for 170. At least that was back then, because now you can't really get it anymore, because obviously why would you sell a broken board for $20 if you can fix it for $30 and sell it for 200? But back then there was no YouTube. Well, maybe there was, but when was YouTube first announced or actually available? Like 2004 or 5, something like that. Yeah, so maybe there wasn't YouTube yet. So the knowledge acquisition was not as easy as it is nowadays. It was tricky back then. So the best way was to just know someone who can teach you, show you, that kind of stuff. And that's how I got into this. I had plenty of friends working in repair business, because a friend of mine used to import broken stuff from behind our western border. So you would pretty much bring it to the country as trash, then fix it and sell it. And the best, for a few years, the best business was CRT monitors. You don't see that stuff anymore, obviously, for a good reason. But they would sell nicely. And the repair, I was actually not good at CRT repairs. And a very common reason, a big high voltage transformer that generates high voltage for the tube, and there was a lot of circuitry around it to maintain, to check whether it's working properly, and because that's high voltage, so that was required, so it doesn't hurt anybody. And the other ones, the simpler ones that I actually did manage to fix were power supply issues. So power supply obviously was built in to the board, but every power supply is kind of similar, right? So those I could actually fix sometimes, but I had very, very low success rate with monitors. It required a lot of knowledge, a lot of experience, which I didn't have. So now let's maybe this way. Get some memory over here. Let's get some cooling on the CPU. Which side was it going? I think this way. Or the other way. I have no idea. No, the other way. Yeah, that's why it's shaped like this. Yeah. I'm just gonna place it on just so it doesn't burn. There's already an operating system on the drive. It might not actually boot, but at least it should start trying to boot this time. Or it won't. I would say at this point it's kind of 50-50. If it doesn't, then the problem is somewhere else. And definitely not, because I got 1, 2, 3 caps that I didn't replace, because they're not responsible for anything crucial. These ones over here, on the other hand, that's what stabilizes voltage for the heart of the motherboard. And we could use some power. There. And alright, it is booting. Let's turn on the monitor. Okay, we got BIOS, Dell OptiPlex 755 series. I don't have keyboard connected, so performing IDE configuration, drive 0, disk drive. It's not ready, I can't hear it reading anything, but it looks like it's doing the same thing. So recapping definitely didn't hurt it. It definitely needed to be done either way, but that was not our issue. This is heating up, but then reasonably, and this is not heating up yet. Okay, so it's the same issue. It's just sitting on the BIOS page after the drive was detected. I don't hear the drive making any sounds because this is the regular disk, so you can distinctly hear it when it's reading or writing, and this one is not doing anything. So 2 more options. I really doubt these 3 caps that I haven't replaced are at fault, but maybe. So maybe I'll try replacing those and try this again. But since it made no difference, the issue might be somewhere else. Well, the issue is somewhere else. That's too bad. I was really hoping to fix this one, but nope. And it's not like I can return it after like a few months. But hang on, this little guy. This one might also be crucial. Also, the capacitance of these, it's like half, more than or less than a half of original capacitance. So that might also be part of the issue. But I'm gonna deem this one no fix. Well, actually, I will replace later. I'll replace those 4 more caps, especially this one, this little one over here, and see if that makes any difference. But we should see at least some difference now after replacing most of these. And yeah, the battery, it shouldn't. Well, I don't know if anyone knows whether the battery could cause the lack of battery could cause this problem, then definitely leave a comment. And I don't know, I might play a little longer with this one. Maybe I can find some at least block diagrams for this board. That would help a lot. But this is a bit too complex to just diagnose it like that without schematics and at least some experience fixing those particular boards, because I'm sure this should tell me something, that it's freezing just as the system starts to boot. So probably chipset is at fault, most likely, I would say, because that's what actually you do have BIOS in the chipset, right? Or is the BIOS somewhere else? See, I don't even know that, so that's kind of hard to deduce anything based on the symptoms without this fundamental knowledge of these boards. Well, for now it's no fix, too bad, but what are you gonna do? You can't fix everything. Thank you guys for watching, and I shall see you in the next one.